In the last video I talked about signing assemblies and I talked about public keys. And the reason why we want to sign our assemblies is so that nobody can spoof our code and say, oh, we created the form, it's the same form, I'm the same person. No. No, if I sign my assembly, it is pretty much legally bound digitally, and you know that that assembly came from me. Now, in order to talk about public key, public key, it's called public key private key encryption. And I am by no means a guru on this topic. I did a little Googling off screen. I typed, I think, public key, private key, or public private key, or something like that. And up popped this. I found this to be an excellent article. Excellent article. It talks about public key, private key, that kind of thing. Let me explain public key and private key as much as I understand it. If I want to verify that something's from me, then I need to make a public and private key, and the keys are important for the encryption algorithm. They have to work together. And so what I do is the private key, I'll just say private key. It's private. It's something I need to keep. And by key, it's just a big fat number. Right? It's a seed. It's into the encryption algorithm. But it's a number I keep. And then the public key, I can make it publicly visible. I can put it out a classified ad. I can do whatever I want to. And so this is the public key. I can say, this is my public key, world. Here you go. And so now that I have this private key, public key, I can prove that a message came from me by encrypting that message using my private key. Say I want to give a message to the world like, I like peanuts. Right? And that'd be a nice thing to send to the world. But in order for the world to believe that I like peanuts, they have to verify that this message actually came from me. One thing that's easy to do, actually it's kind of fun, is to do some email spoofing. Maybe I should do a video on email spoofing. But it's really easy to spoof an email like an email came from somebody else. You could write up a fake email, write a little bit of C# code, send the email on behalf of somebody else, and all of a sudden it looks like somebody sent an email that they actually didn't send, and that's really scary. And so we need to verify that these messages actually came from their publisher using the public key, private key encryption. And so anyway, I take the encryption algorithm, and I'll just draw it as a box, but it's this encryption algorithm box, and I feed it my message, I like peanuts. I feed it my private key, which is a big fat number, and out pops some gibbly gop. Okay? And if you want to decode this message, that's fine. What you have to do, I think we're done with these arrows. I fed my message and I fed my private key into the box. What I have to do is take that gibbly gop, feed it back into the box with the public key, and out will pop, let me get all that off there, out will pop the message, I like peanuts, right, off the viewing area of your screen. But you get the idea that, okay, I feed a message and a private key into the encryption algorithm, out pops gibbly gop, and then I can feed the gibbly gop and the public key into the encryption algorithm, and out pops the actual message. Now, if out pops gibbly gop, say you feed the gibbly gop I created and the public key into this box, and out pops something that didn't make any sense, then you know that I didn't create that message. All right, it didn't decode anything useful. So that's kind of the gist with public key, private key. And we use the same concept with assemblies. When we sign our assembly, we sign them with a private key. And then at the other end, when you as the consumer, load up my assembly and you run the public key algorithm on it with a hash I'll talk about a little bit later, you can verify, hey, we either get the right value or we don't. And if we don't get the right value, then something's wrong and we're not going to trust this assembly. So I'll talk about that in more detail in future videos. For now, I just want to show you, hey, let's create a public key, private key, and actually use it. First of all, we need to create a public key and a private key. And you can, everything I do on the command line here, you can have Visual Studio do. Generally through the project properties, you can have Visual Studio create a public key, a private key. You can have Visual Studio sign the assembly. Ideally, you have Visual Studio do everything for you automatically. I just like to do it on the command line so you get a feel for what's really going on. So let's create a public key, private key. They're free. All you have to do is create them. You don't have to pay for these. It's actually kind of nice. You have to use this utility called the strong name tool. When you sign an assembly, you're giving it a strong name, which I guess is better than a sissy name. A sissy name is just binding off the name. We've seen that in previous videos. But a strong name is like, we're going to use everything, especially the public key. Okay, it's a strong name. It's encrypted. It's I don't know why they use strong name. Whatever. Strong name. If you just hit enter, you get loads of options here, and you can kind of pick through all these. But the one we're interested right now is -K. Generate a new key pair, specify size. Write it into out file. So let me clear the screen and say strong name tool. I need a key file, and I'm going to call it Jamie's key dot strong name key. How about that? Hit enter, and key pair written to Jamie's King SNK. So now here I have this key file. Let's see if we can find out what's in it. Jamie's key. I'm gonna hit say type, which should tell me all the contents of the key, and that's looking very Ghibli gosh. Okay, it's all binary data and encryption stuff. There's a inside that file. Let me list the contents again. Inside of that file is a public key, and also a private key. All right, private key. And in theory, there is no way for anybody to get the exact same key as me. And as I'm about to show you, the odds of getting the exact same key when generating key file, the exact same key as anybody has, is near zero, almost impossible. Why? Well, let's see if we can actually look at the keys that were generated in this file. There's a few more options here. I can say SN. Let's look at here and see how we can look at the actual keys inside the file. Right here, extract public key from key pair. We can't actually look at the private key. We can only look at the public key. Extract public key from key pair. Export it to out file. Okay, so strong name tool -P. I think we call it Jamie's key sync. And I'm going to say my public key dot. The extension really doesn't matter. I'll just say pub key. How about that? Pub key. And so what the strong name tool did is it looked in this key file and extracted my public key and put it in this public key file. It's another file. Lists the contents. Let's clear the screen first. Lists the contents of the directory, and now we have this pub key file. And now I'm going to say strong name tool. I want to actually see the public key inside of the pub key file. So my pub key. All right, hit enter, and woo! Look at that. I told you it was just a big fat number. This is a hexadecimal number. If you look, there's an A's and A through F's, but nothing else. It's big fat hex numbers. So chances are when you generate a key and I generate a key and millions of other people around the world are generating keys, we're not going to come up with the same key. Now there's this thing called a public key token, which is a hash on the actual public key. And I'll talk about that in future. But generally, when we're referencing other assemblies, we're only worried about the public key token, not the public key. We'll worry about that in a minute. Let's actually use this. Oops, I just did the screen shake thing and got Visual Studio off of my screen. Let's actually use this key file to do something interesting. Let's do the exact same file we had before, where we had the cow and the moo and the assembly version. I'm actually going to take this back to 1 though. 1. And now I want to compile this file like we did before, but I want to sign it with this key file, this strong name key file, Jamie's key. Now this file, this Jamie's key dot strong name key, as long as I keep this file secure, nobody can spoof me. Right? Ideally, I keep it locked away in a vault. I've heard stories of people putting them on flash drives and saving it away, and only special people with physical keys that can unlock those not the drop boxes, the deposit boxes and banks or whatever can get this out. So very sensitive file. I want to compile this code and actually sign it. So let's say C# compiler. We have a key file, and it's called Jamie's key.strongname key. And then please compile main class.cs, but we want to make it a library and we want to call it farm.dll, just like we did in a couple of previous videos. Run that. The compiler grinds. Let's clear the screen, list the contents of the directory, and here we go. Here's fram.dll. Why did I call it fram.dll? I typed it incorrectly, but we'll roll with that. So we have our cow in there, assembly version 1, that sort of thing. I'm going to comment this out. Let's bring main class back in here. Remember, main class is just calling cow moo. We're calling that cow moo inside of our fram assembly instead of our farm assembly. So now I'm going to say, hey, C# compiler, let's reference fram.dll. The assembly name is now fram. And compile main class.cs. Hit enter. And the compiler complains because I did not save this file. Let's save it. Hit the up arrow. Try again. Okay. Now we're getting somewhere. I'm going to say main class.exe. Hit enter and moo version 1. Moo version 1. Very good. Very good. Now let's play the role of the virus. All right. Let's bring this back in. I think we're done with main class down here. Comment that out. Assembly version. Yeah, assembly version 1. Let's play the role of the virus. And instead of saying moo version 1, I'm going to say I am a virus doing bad things, trying to spoof the fram assembly. Okay, hopefully you get the idea. So we made our drawing in white's not going to work. We made our main class exe. We compiled against a fram assembly instead of a farm assembly, a fram assembly, which was signed with Jamie's key. All right, Jamie's stamp of approval. All right, now we're going to overwrite this file. We're going to erase it and create a new fram. And we're not going to sign this one. We're just going to try to spoof it and be a virus and do bad things. So let's make sure I save this file. I do, and bring up the command prompt. And I'm just going to hit the up arrow, try to find the command we did to compile that before. Here, same thing as before, but now I'm going to take the key file off because ideally I didn't share my key file with bad programmers. So they just say, hey, let's make a library. Let's call it fram.dll like the other one. Overwrite the old one. And now when you try to, let's list the contents of the directory. Now when you try to run main class.exe, hit enter, we get an exception saying, cannot load file or assembly fram. Wait a minute, fram's there. It's right there, fram. Version 1, it is version 1. Culture neutral. Oh, we didn't specify culture, so it's neutral. Ooh, public key token. I'm looking for an assembly named fram with this version, this culture, with this public key token. Now, what's the public key token? If you recall, we did that strong name utility -tp, and where was the public key? My public key .pub key. The public key was this big, long, huge, let's do a different color that might show up, huge key, and this is the actual key that's used for hashing and that sort of thing we'll talk about in the future video. But when we actually reference assemblies, we only reference them by this public key token, which is yet another hash off of this big fat public key. And the reason why we use public key tokens when referencing DLLs, remember we had main class, and it was referencing the fram. Well, inside of the main class assembly, we don't necessarily want to store all this data. In fact, if main class, you could picture main class referencing maybe 20, 30 other assemblies, and for every assembly it wants to store this, and that'd be hideous. So what it stores instead is this public key token, which is yet another hash on the actual public key. It's a token off the public key. So when .NET turns around and says, well, let's load up the assembly, and we're looking for this one with this public key token. Well, this fram.dll, since it wasn't signed by Jamie's key, the .NET's not satisfied and says, I can't find this assembly. All right, and again, this comes back to how we locate assemblies. Back in the day with C++, all we cared about with external libraries was, hey, is it the right name with a .dll on the end? Whereas .NET says, I don't really care about the DLL. I'm looking for the .dll just so I can load the assembly up. But once I have the assembly, what I'm really looking for is the entire name, the full name with the basic simple name, the version, the culture, and the public key token. These things which I've described in previous videos. Anyway, that's signing your assembly. That's trying to spoof another assembly. We're going to take this further and examine it farther in future videos.